November 2025, at its flagship developer conference, Baidu quietly dropped a bombshell. It unveiled brand new AI chips built in China, signaling an ambitious bid to reduce dependence on foreign technology and challenge Nvidia's global dominance. The announcement didn't come with flashy hype or fanfare. Instead, it came with a roadmap, technical realism, and the message: the battlefield for the future of AI is shifting, from Silicon Valley to the East. The moment that jolted the AI world. For years, Nvidia reigned supreme in AI hardware. Its GPUs powered the majority of large language models, generative AI systems, data centers, and cloud AI services around the world. From research labs to startups to global tech firms, nearly every serious AI project relied, at least in part, on Nvidia's hardware muscle. The global supply chains, software libraries, developer tools, all had been optimized around Nvidia's architecture. Then, on 13 November 2025, Baidu revealed that it will launch two new AI chips: the M100 hardware designed for inference, and the M300 aimed at both training and inference of large models. Alongside these chips, Baidu unveiled plans for supernode systems, clusters that network many chips together to scale performance for large multimodal models. This is not just a product launch. It marks a strategic milestone. A major AI company from China publicly claiming it can meet domestic AI demand with homegrown chips and offering an alternative to Nvidia, long considered unassailable. As trade tensions, export restrictions, and geopolitical tensions continue to shape tech access globally, Baidu's move resembled a shot across the bow. The message: the era of foreign chip dependency might be ending. Suddenly, the global AI hardware landscape doesn't feel inevitable anymore. It feels contested. What Baidu's chips are: technical ambition meets national strategy. The technical ambition behind Baidu's reveal is substantial. The M100 chip is designed for inference, the stage when trained AI models generate output. The M300, launching around 2027, is slated for both training and inference, enabling the development and deployment of massive multimodal AI models entirely on domestically made hardware. Baidu didn't build these chips overnight. Through its semiconductor subsidiary Kunlunxin, itself spun out years ago, Baidu has been developing AI processors since 2011. Previously, Kunlun series chips served internal needs, powering Baidu's search infrastructure, its AI services, and early model training tasks. With M100 and M300, Baidu aims to match or approach the functionality that until now only foreign-made chips could offer: high-throughput inference, large model training, memory and compute for multimodal workloads. Everything from natural language, image, video, and perhaps even future robotics AI, all using domestic hardware. In addition to standalone chips, Baidu is offering supernode systems, clusters of many chips networked together, offering scalability comparable to server-grade AI clusters. This suggests Baidu isn't just trying to make a chip, it's building an ecosystem: hardware, software, AI models, cloud infrastructure, all under its control. That ecosystem matters because it aims to remove reliance on foreign supply chains, avoid export restrictions, and foster a self-sufficient AI stack for China. Analysts writing about the announcement described it as a clear sign that China is intensifying its push for AI sovereignty. Domestic firms will have powerful, lower-cost, and controllable computing power at home. In short, Baidu isn't simply building chips, it is building a strategic alternative: a domestic AI infrastructure that could rival global players. Why this matters: a shift in the global power balance. Until now, AI hardware has had heavy centralization. A handful of firms, mostly in the US, designed and manufactured the chips. Software frameworks, model architectures, training scripts, cloud services, almost everything was tuned for those chips. This created a powerful ecosystem barrier for competitors. Even if a firm doubted reliance on foreign tech, the cost of building a full stack, hardware, software, and data infrastructure was prohibitively high. That's changing. Baidu's announcement shows that building a domestic stack is possible and viable. For companies in China, especially after export restrictions from the US, this becomes not just an option, but a necessity. With chips built locally, models trained locally, data stored locally, an entire AI industry can be built within national boundaries. This matters geopolitically. The trade wars, export restrictions, and tech decoupling between superpowers have made hardware sovereignty more than an economic objective, a strategic imperative. Baidu's chips respond directly to that shift. For global AI, this could mean fragmentation. Instead of a unified global ecosystem with Nvidia at its core, we may see parallel stacks, one centered around Nvidia and US/Western tools, and another around Chinese-built hardware, with different tool chains, frameworks, data flows, regulatory environments. We may enter an era of AI blocks where companies build for one ecosystem or the other. That fragmentation will influence everything: model architecture design, data sharing, deployment, cross-border AI collaborations, even regulatory compliance. The global AI race will become not just technical, but geopolitical and economic. Moreover, competition tends to drive innovation. As Baidu and other Chinese firms pour resources into chip design, we are likely to see faster advances in AI hardware globally. Performance, efficiency, specialization, and price pressure may accelerate. As hardware becomes more varied and accessible, new startups and research labs anywhere, not just in the US, may participate in cutting-edge AI development. In effect, Baidu's move could democratize AI hardware globally, while also reshaping who leads, how, and where. What challenges Baidu faces, why this fight won't be easy. The ambition is enormous, but so are the challenges. Overcoming Nvidia's dominance, global developer inertia, software ecosystem lock-in, and the complexity of building large-scale AI infrastructure will not be trivial. First, ecosystem maturity. Nvidia's hardware advantage isn't just silicon, it is decades of software optimization, libraries, developer tools, model compilers, community projects. Many AI frameworks assume Nvidia's GPU architecture. Translating or rebuilding that entire stack for a new chip architecture is a massive undertaking. Without broad third-party support, new chips risk being limited to in-house use or niche projects. Second, performance gap. While Baidu promises M100 in 2026 and M300 in 2027, details on raw performance, memory bandwidth, flops, latency, support for large-scale models remain scarce. Competing with top-tier Nvidia chips, especially in training massive multimodal or foundation models, will require not only hardware parity but also exceptional production quality, cooling, power efficiency, and reliability. Third, market trust and adoption. Many enterprises, both inside China and globally, are cautious about transitioning mission-critical AI workloads to unproven hardware. Convincing companies to adopt a new stack involves overcoming inertia, compatibility concerns, and risk. Until Baidu's chips prove themselves at scale, adoption may remain limited. Fourth, regulatory and supply chain uncertainty. While domestic chips can mitigate export restrictions, they still depend on global semiconductor supply chains for materials, fabrication, testing, and distribution. Geopolitical tensions, supply chain constraints, and export controls on fabrication equipment may slow progress. Finally, fragmentation risk. As new hardware ecosystems emerge, the AI community could splinter. Models trained on one stack may not run on another. Collaboration, open source sharing, cross-border research may suffer. Standardization becomes harder. The advantage of a universal platform is lost, replaced by competing standards, compatibility layers, and technical friction. Baidu's path is bold, but the road ahead will be rocky. Success depends not just on silicon, but on community, trust, infrastructure, and timing. What this could mean for AI researchers, startups, and the broader industry. The impact could ripple across the entire AI world. For researchers and startups, new hardware alternatives mean lower entry barriers. Instead of needing expensive cloud instances at Western data centers, they might access capable AI infrastructure locally, possibly at lower cost and with fewer export or geopolitical constraints. This could spur a wave of innovation in places previously sidelined by hardware access limitations. Universities, research labs, AI labs in Asia, Africa, Latin America, all could deploy advanced models using domestically available chips. That democratization might lead to a broader diversity of AI applications, datasets, and participants. For AI infrastructure vendors, Baidu's move expands the market. Instead of serving mostly Western clients, hardware vendors, software tooling companies, model deployment platforms, and cloud providers may now target a growing domestic Chinese AI ecosystem. That could encourage a parallel industry cluster with domestic tools, languages, frameworks, and specialized services. In addition, the competitive pressure on Nvidia could drive global innovation. Price pressures, performance optimizations, greater focus on efficiency, and freer architectural experimentation could arise as companies try to stay ahead of challengers. We might see broader efforts to design AI-specific hardware beyond traditional GPU, including domain-specific accelerators, hybrid CPU-NPU designs, or even neuromorphic chips. At the geopolitical level, a more balanced global AI hardware landscape changes leverage. Countries that once relied on US-made chips may now have viable domestic alternatives, reducing vulnerability to export controls, sanctions, or supply chain disruptions. For nations pursuing AI sovereignty, the path forward becomes clearer. In short, Baidu's announcement could mark the beginning of a more pluralistic, diversified, and contested global AI ecosystem, where dominance is no longer concentrated and innovation might come from unexpected places. Why this moment feels like a turning point. AI has always been about software, algorithms, data, models. Hardware was the enabler. For a long time, that hardware came mostly from one source: standardized GPUs from a handful of producers. That standardization had benefits: compatibility, predictability, scale. But it also centralized control. Now, with Baidu's chips and the broader trend of domestic AI hardware development, from China, from other regions, we may be entering an era of hardware pluralism. The monopoly of a single hardware architecture could be ending. Instead, the AI world may fracture into ecosystems, each with its architecture, trade-offs, strengths, and communities. That could be a moment of enormous creativity. New architectures prompt new research, new software, new techniques. Just as the rise of mobile computing forced software to adapt, the rise of diverse AI hardware will push AI research into new directions. Efficiency optimization, cross-platform portability, model compression, hardware-aware training, domain-specific models, and more. For users, this could mean faster, cheaper, and more widely available AI services. For governments and societies, it could mean more resilience, less dependence on foreign tech, and greater local control. For the AI industry, it could mean disruption, risk, but also opportunity. Baidu's M100 and M300 chips and the supernode strategy might be the opening act of a new chapter. If they succeed, the global balance of AI power could shift substantially. If you want to stay up to date with how the AI landscape is being reshaped, not just by software, but by chips, hardware wars, and national strategy, subscribe for more deep dives. Share this with someone curious about how the rules of AI dominance are changing. Hit like if you believe the future of artificial intelligence may be decided in hardware labs, not just on GitHub. Stay tuned, because this isn't a trend, it's a tectonic shift.